Good afternoon. Welcome to the Sustainability and Energy webinar series. This series is sponsored by the Engineering Construction Division of the Corps of Engineers. It is being recorded, and today we are focusing on a presentation by Brandon Martin on construction quality assurance for energy performance. We do these webinars in sessions of five, groups of five. And if you want to get credit for AIA or other CEUs, learning units, then you can go to the Mercy site. If you haven't created a login already, you need to create one, and download the quiz. The quizzes, again, as I said, are in batches of 5. Submit your answers to the website on the screen, s_e webinar@usace.army.mil. And assuming your answers are correct, you will get credit for attending today. Today's webinar will discuss the role of construction quality assurance and management, construction deficiencies and changes, in maintaining design responsibility and the delivery of the energy efficient construction projects. The webinar will include a brief introduction to the factors that impact building energy usage from the design through construction, provide examples of changes and deficiencies and the relative impacts to energy performance, provide construction submittal review examples, and reference relevant regional energy and sustainability centers and prospect courses that may provide detail, support, and training. With that, I'm going to turn it over to Brandon Martin, and he will take it from here.
Good afternoon or good morning, wherever you are. I'm Brandon Martin. I'm the Chief of Mechanical Design at the Louisville District Corps of Engineers. We do energy assurance today and how it impacts energy performance. So bear with me, I'm getting used to the tools on this thing. Okay, so we have public laws, Army policy, DoD policy, regulations, all that require us to optimize our energy performance. So we tend to focus a lot on the design stage of the construction process, and to some extent on the operation and maintenance phase. We're getting into energy audits now, recommissioning, things of that sort. We don't see a lot of focus, I guess, on the construction phase of this process as it relates to energy performance. But as we all are aware, if it's not constructed properly, it will not perform properly. So we're going to talk a little bit about factors that affect energy performance. We'll talk about how field changes can impact energy performance and specific examples, and then we'll talk about various activities in performing quality assurance for systems and features that impact energy performance. Okay, so we have an Army SDD policy, came out in 2013, that requires that we achieve the highest energy efficiency that is life cycle cost effective within the program amount. It also goes on to state that energy efficiency is a mission objective and it competes equally with other mission requirements defined by the project. So that's a pretty big deal. And instead of energy performance taking a back seat to everything else we have to be concerned about, we're actually supposed to consider energy efficiency a mission requirement. Some of the things that affect, actually, how do we determine what the best or the most energy efficient system is that's life cycle cost effective? We have to consider not only the energy performance, but the construction cost, maintenance costs, operating costs, and salvage value. That's all of the parameters that go into a life cycle cost analysis. We need some input from the operating and maintenance staff on their actual maintenance and operation practices. We also need to make sure we really understand the functional requirements of the facility. Just like any project, we're building the facility for a specific purpose. We need to understand that purpose. The better we understand the purpose, the better we're going to be able to optimize around meeting that particular purpose. The systems that affect energy performance: building envelope, lighting systems, HVAC systems, plumbing systems, typically the domestic hot water, and energy generation. So generators or renewable energy systems. So those are factors that influence design for energy performance. On the other side of construction, we have operation and maintenance. Once we turn the building over, yes, operation and maintenance do have a huge impact on energy performance. How do the building users and operators use the facility? What are the schedules or the occupancy patterns? When do they come in the morning? When do they leave at night? What kind of equipment do they use in the facilities? Have they doubled the computing power that they use in the facility? That changes things. How do they correct problems when they arise? How do they correct the control systems? Do they bypass controls and have the system running in an inefficient manner unnecessarily? Those things can happen. Maintenance has a big impact. If they're not maintaining the equipment, you could have actually energy savings if a fan belt breaks and the fan's not running. I've actually walked into a mechanical room where an outdoor air system was not functioning because the fan belt had been broken. Nobody had been out to fix it. So that building is actually saving energy. It's probably not very comfortable or healthy. On the other side, often controls are bypassed, or when they have failing actuators on dampers or things like that, they'll find some way to lock those things wide open so that we're not controlling the amount of energy we use, and those cost us energy. So those are ways that operation and maintenance can impact energy use. What are ways that we can help? Being at the Corps of Engineers and being design and construction agents, we don't operate the facilities, but what can we do? We can concentrate on occupant maintenance training, making sure that training is worthwhile. We can make sure that we turn over usable system manuals, maintenance plans, service life plans. We need to review building operation post-occupancy. After we turn the building over, that's when we find out if the design is worth anything by looking at trend logs, making sure that everything's running the way it's supposed to under the load it was actually designed to handle. We don't really know at the end of construction whether the design is going to function. The only test of the design comes when the building's already occupied. So it's a follow-up measure we need to take. The focus today is on construction. So we have a pretty good construction quality assurance process. We rely on the contractor to be fully responsible to adhere to contract and design documents. He's responsible for his own quality. Our role is to oversee his quality efforts to make sure they are implementing quality control adequately. So we are not inspecting everything. We're not testing every little thing. We're making sure that to the extent that quality control for the contractor is executing those tasks, those are executed correctly and they are and sufficiently. Commissioning is really a quality assurance process that the Corps does anyway. We review submittals, we inspect, we test. But what commissioning brings is a higher level of technical competency. So we use team members that are experts in their fields to put a lot more focus on the systems that we know we're going to have trouble, typically HVAC systems, and to a lesser extent electrical systems, and now building envelope systems. The intent of all of this is to make sure we build as designed. Because as we know, if the building is not built per the design, the energy performance isn't going to be there. It was designed to have a specific energy performance. If we don't have the construction per design, we won't hit the targets that we've set for ourselves. So what are the activities we do in construction? So this is really Construction Management 101 or Construction Quality Assurance 101. We review equipment, materials, shop drawings, any of the submittals related to the equipment that's going to be installed. We inspect the equipment once it's installed. We make sure the correct equipment has been put in place. We make sure the building envelope components have been connected correctly. We make sure the mechanical systems are wired, they have controls, they've been balanced. And we perform tests on all of these things. We do air tightness tests, we do thermographic envelope inspection, duct leakage tests. There's plenty of examples that I'll cover later. Those are the activities we go through, and we do those with the quality control people on the contractor staff. We're not coming in and doing this independently. We work with the quality control people to make sure they're doing this stuff correctly. On the sheet here, or the slide here, you see an example of a cut sheet. It's an example of a submittal for an air handling unit. It happens to have energy recovery in it, and what you're seeing there is the equipment performance data. So this is an example of where we would look at submittals to make sure the performance matches what was in the design. And we don't want to focus solely on energy performance when we look at these, obviously. We have functional requirements. So the performance, intended performance here, the priorities are to achieve thermal comfort. We don't put HVAC systems in to save energy. We put them in to achieve thermal comfort, a healthy environment. We make sure we provide fresh air. We try to avoid mold. So we're optimizing those for those things. Next, we need to make sure the operation and maintenance staff can actually maintain the systems. Can they access the systems for maintenance? Can they pull coils? Can they get to the filters? Can they access controls? If they can't do those things, eventually that system is going to fail. It won't even meet the functional requirements of the facility and may not meet the energy performance required for the facility. And then finally, we need to make sure that the systems operate efficiently, which is the focus of this presentation. So just some, I'm not going to teach a class on quality assurance. A lot of people on the webinar, I'm sure, are experts in quality assurance and construction management. Here's some prospect courses that can help construction reps and engineers to get a handle on this. There's the construction quality management course. There's electrical and mechanical quality verification courses. There's an HVAC commissioning course. The HVAC commissioning course is really good. It has a couple of days of actual lab, hands-on lab, working on systems. Those can be found in the Purple Book. Obviously, the United States Learning Center has a lot of courses in just about any field. If you go to the Purple Book, you can find a lot of courses. There's also a Regional Energy and Sustainability Center for commissioning. It's North Atlantic Division. I've attached a couple of websites there. I'll also point out that Fort Worth has been building a commissioning program. They have a staff that's, I don't know what the capacity is at the moment, but if you have need help in commissioning, they can help you, as well as Louisville District. All right, so what happens when we actually change things in the field? Well, first, to get a handle on what the impact is, let's talk about energy models for a moment. So energy models are a design tool. We use them to select the best systems features for the facilities. We use life cycle cost analyses also. So when we make design decisions, the way those decisions are made for a particular facility is done through energy modeling and life cycle cost analysis, also including input from installations for our customers. So we are trying to achieve a balance of functionality, cost, maintenance, operability, and energy performance. So a lot of effort goes into that. That could be weeks and weeks of effort put into selecting the features and systems we put into that facility. Another type of energy model we often do is compliance model. So we try to show that we've met the LEED Silver target, or we've met the Energy Policy Act target. Those are mandates. We have to do an energy model to show that we met those, and that's based on the actual design. So if we're changing things in construction, we're actually invalidating our compliance model, the documentation that shows we're compliant, unless we adjust that later after construction or during construction. Another type of energy model is a predictive model. This is a model we don't typically do right now. It predicts the actual energy usage of a facility. So compliance model has a set of rules that really preclude it from being very useful as a predictive model. So there's a separate way of modeling it that you can predict what the energy usage of the facility will be. However, there's a lot of assumptions that go into that about whether and how the facility is going to be used. So to be useful after construction and after the facility has been used for a while, data is collected, that model is recalibrated to reflect reality more closely. But those models can help you determine what your utility bill might look like. You can use it to determine if the facility is operated differently, if I change the schedule, if I change the occupancy from everybody coming in at 7 to everybody coming in at 6, what does that do to my energy usage? You could also look at performance changes if you add energy conservation measures. But if we deviate very far in construction from what was designed, then all of this becomes invalid. All of the work that was spent in design, all of the interaction with the customers, the stakeholders, all the energy modeling, life cycle cost analyses, all of it, at a certain point, once we deviate so far, all of that becomes invalid. And actually, in order to still show compliance with Energy Policy Act, if something changes enough, we ought to go back and redo the energy model. Okay, so we need to maintain design responsibility. So again, that we have spent all this time working with the customer doing energy models. I know I keep saying that, but the point is, the AE who did all this work, he's somewhat responsible for the energy performance of the building. If we go around making changes, allowing customers to make certain changes, if the contractor misses something in the contract, installs something incorrectly, and we're contemplating letting it go or just getting a credit, we need to think about that pretty hard. We need to think about what is the energy impact of that. Do we just let it go? Does the contractor owe us something? Do we need to redo the energy model? How are we going to handle this? So we need to maintain design responsibility. So the only way to do this is to have somebody on staff or go back to the AE that can use some judgment based on what's changing on whether an energy model might have to be updated and the results of that considered before we make a change. So whether that's reaching out to your quality management folks in construction or to your engineering office or back to the AE, there are different ways to approach that depending on your contract vehicles and what you have. But these things can make a big, can be a big deal. Here's an example. Let's see, use the pointer. So here's an example. What if the user wants to change a wall or roof color? That's not really going to make a lot of difference. I'll show you why in a second. But what if the contractor put in the wrong window type? He has the wrong U value for windows. That could be a pretty big deal. It not only can affect energy performance, but it could affect whether the HVAC system is going to keep you comfortable or not. So that stuff needs to be considered. We can't just decide, oh, well, he owes us a credit and let it go. What about the other effects to the systems? But what about our energy performance? So let's not brush it under the rug. We need to make sure we consider that. I'm sorry. The process would be after the contractor makes a request for a deviation, makes a request of deviation or variance or deficiency is identified, the Corps needs to determine whether AE response is required. So the AE needs to know if something major has changed because they have design liability. If something goes wrong later and we've changed something and not had the designer involved, we lose AE liability. We don't have a lot of recourse then. You can use again, your technical people in the district to determine whether that's necessary. The AE anticipates the level of impact to the energy performance and determines whether an energy model update is necessary. If we're going to do something minor, change a roof color or a wall color, he may tell us, hey, we don't really need to do anything to the energy model. It doesn't make a lot of difference. On the other hand, if the windows have been installed or the wrong windows have been installed, he may tell us, hey, we really ought to rerun the energy model quickly and determine what kind of difference this is going to make. Once they determine that something has to be analyzed, they need to assess the energy performance impact and make recommendations. And then the Corps needs to approve or disapprove, not just based on that. Obviously, the change, some of this has to do with partnering with the contractor. Some of this has to do with whether we need a credit to pay for something else. Some of it might be a customer requested change. But part of the consideration should be what are the energy impacts, and not just energy, but energy cost impacts, and perhaps even maintenance cost impacts. One key point here is to make sure the USA's field office has a copy of the design analysis in order to help make a determination on whether this needs to go back to an AE or to do anything about this from an energy perspective. We don't have the calculations. We don't have a chance, even close to a chance of determining what kind of impact we're going to have. How does this change? So we just talked about design, bid, build. I'm talking about design, build. How does that change? Well, we're headed towards using more prescriptive contracts. ECB 2015-7 was just released maybe a month or two ago. That requires for design build contracts we perform optimization during the RFP development stage. And then we incorporate prescriptive measures into the RFP. That's how we achieve our energy optimization. We tell the contractor what we already know is the best answer. That's pretty easy to enforce. All we need to do is make sure that he installs exactly what's in the RFP. If he's changed something through his contract proposal and we've accepted that, then we would look at the contractor proposal as part of the contract requirements, make sure they've included the items that they've submitted. Deviations need to be handled the same as for design, bid, build. So this time the AE is the RFP developer. He performed the energy optimization. He said this is what needs to be done for this facility. And if there's a deviation from that, that AE needs to be involved in helping us decide how to address that from an energy perspective. This gets a little harder when you talk about performance contracts, which is what we've typically done in the last 10 years or so with design build. Different ways to handle energy performance is requiring a flat energy percent reduction. So the contractor performs an energy model, decides what types of systems he needs to meet that, generally the cheapest thing he can give us to meet that requirement, and that's what we get. We may ask for the most energy efficient within the funds available. And so then it's a contest when we look at the proposals from contractors to determine what are the best systems we're going to get and what are the most efficient within the cost or the funds that we have available. That becomes the contract requirement. We might ask for the most life cycle cost effective. I don't want to even get into how this is somewhat of a mistake in trying to ask after award, after we've paid a fixed price, to have a contractor determine what is most life cycle cost effective for us. But anyway, we do that sometimes. So any deviation or variance impacting energy performance needs to be approved by the designer of record and should come with an updated energy model. So let's say that the designer of record modeled a air handling system, VAV air handling system with an energy recovery wheel. Let's say the contractor has a bright idea during construction. He's not going to put in an energy recovery wheel. Often we know that design build turns into build design, where the contractor does whatever the heck he wants during construction. He turns around and asks the designer if that's acceptable. The contractor says, "You're paying me. Heck yeah, that's acceptable." So we end up with that energy recovery wheel. And if the RFP was not prescriptive enough to require that, we can't do a lot about it. We might have a fit, but that's about all. If he's going to do that, he owes us an updated energy model. He has just changed the energy performance, and that was one of the contract requirements. So he needs to prove that he still met the contract requirements. You might find that, well, gee, I really do have to have an energy recovery wheel. If we let that go, we're hurting ourselves. We're incurring more operating costs. Under no condition should we allow a contractor, on a design build contractor, to impose higher operating and maintenance costs on the government without challenging that. So, are all energy factors, or all factors that relate to energy performance equal? No. Different energy features, energy conservation features and systems have different impacts. And we don't need to concentrate on each of them equally. The magnitude of those impacts depends on a lot of different factors. It depends on the building size, the climate, utility rates, the internal heat gains, what's the operating schedule, what's the occupant density, how much available daylight. All those things have an impact on energy And so an example would be the window performance for a 100,000 square foot office building at Fort Drum is a far larger issue than the same change for a 10,000 square foot vehicle maintenance facility at Fort Bragg. We may be less concerned with the window performance at Fort Bragg in this 10,000 square foot facility than we would with this larger facility in a colder climate. As an example, here are different energy efficiency measures, or these may represent deficiencies within the construction. Air barriers are a huge deal. So just having a slip in your air barrier or air, say your air tightness test results in 0.35 CFM per square foot at 75 pascals rather than the currently required 0.25 CFM per square foot. That can make up to a 10% difference in your energy use. I will point out again, this is case specific. In this case, this is a half office, half readiness area. It's 100,000 square foot at Fort Campbell, Kentucky. And the system involved here is air handling units with DX cooling and gas heat. But in this case, it does make a huge difference. Look down here at wall and roof color. It doesn't really make much difference. We hear a lot about that, cool roofs and everything, but how much difference does it really make? It depends on the climate, again, and it depends on the type of facility. But in this case, it doesn't make much difference. I'm probably not going to have a huge fit if the roof ends up being a darker color than what was specified, provided the customer accepts that. You can look at these at your own leisure to see the different impacts, but notice the big ones are air barrier, system effect, what we call system effect in the mechanical system. So let's say the contractor installs ductwork in a poor configuration coming out of a fan. Maybe it didn't match design. Perhaps somebody decided to allow the contractor to put fire alarm panels not far from the air handling unit, which compressed the amount of space available to run ductwork coming out of the air handling unit. So we have ductwork that does not conform to design. And those poor conditions can have a significant impact, just as much as having a big decrease in air barrier performance. Another one to look at is lighting. Just a change of 0.1 watts per square foot can have up to a 4% impact on energy performance. Some of those small ones, these are architectural shades. Those are projections, or where the window is inset into the wall somewhat. They may not make much of a difference at all. So why get hung up on the dimensions of those? I want to look at it from a different perspective. Let's look at it from utility cost. So these are utility cost impacts. And this time I've shown both a 100,000 square foot building and a 10,000 square foot building. Now this was a pretty simple analysis. Wasn't a lot of data thrown at it. I know that Fort Campbell, when you have a gas and electric energy use mix, the average utility cost is $1 per square foot. So at 10,000 square feet, I just made that a tenth of what the cost would be at 100,000 square feet. Not exactly right, but I'm just showing you a rough order of magnitude. Notice for an air barrier at 100,000 square foot, that change from 0.25 CFM per square foot to 0.35 CFM per square foot is $10,000 a year. That is per year. That's something we do want to pay attention to. For a 10,000 square foot building, it's $1,000 per year. How many times do we want to send somebody out into the field to watch a retest of an air barrier system if it's only going to, if a small difference, or this kind of difference is only going to make $1,000 a year difference? Say that's still a pretty large difference. $1,000 a year over 40 years, $40,000. Might send somebody out several times. But let's look at, again, the wall and roof color, light to dark. For a 100,000 square foot facility, that's only $300 a year. For 10,000, that's $30 a year. I don't know if I can afford to pay somebody to look very close to that, if it's only going to make a $30 a year difference. The only point I'm trying to make here is not everything is equal. We need to apply some sense and some judgment to what we spend our time looking at. This changes for every facility, So your engineer should be able to tell you what kinds of things make a big impact. Perhaps these kinds of things should be put into our considerations for field personnel. Just a suggestion. So again, we need to make sure we prioritize what we spend our time on. Here's a side note. Not only do we need to worry about construction prioritization, we also ought to think about that in design. For a 100,000 square foot facility, my energy modeling might take $50,000 to $80,000 to optimize the facility. That might take 1 to 2 years to pay back, and that's before the equipment or the design or the construction itself starts to pay back. The same 10,000 square foot facility may cost $30,000 to $70,000 to optimize. It may take 7 to 15 years to pay that back, and that's before the construction actually starts to pay back. So there's obviously diminishing returns when we apply this optimization effort to smaller and smaller buildings. Let's ask a question here. When does the energy savings start to pay back? Should we include the cost of performing optimization in the whole building lifecycle cost analysis just to see how that works out? A little bit of, again, that's a side note. So now let's get into actual examples of things we need to be looking at. So air barriers we saw were a big deal. We need to pay attention to our air barriers. Things we need to look at when the submittal for air barrier components are made, or the building envelope components, walls and roofs, we need to make sure that the items that are meant to be air barrier components meet the specified performance requirements for permeability. We need to make sure that the installation is in accordance with connection details. If mock-ups are required, we need to make sure that they're performed, built in and tested. We need to witness the air barrier tests. We need to retest and seal as required. I know there was a webinar not long ago on this very topic, so I'd suggest going back to the YouTube site and reviewing that if you need it. Insulation, we need to make sure that the materials match the design. The products that come on site match what was submitted. We need to make sure we watch out for unintended thermal breaks. Is there insulation that is being broken by structural members that was not intended? One thing to note, don't assume more or less insulation is better. In some cases, more insulation is better. In other cases, less insulation is actually better. It depends on how the building performs. We need to look at windows. Again, this is pretty much the same pattern. We look at what is submitted. Does it meet the performance requirements? Does what's on site match the materials that were submitted? Are the windows being connected to the walls properly? And again, don't assume that higher or lower U values or solar heat gain coefficients are better. We need to try to match the design as closely as possible. If you have a question about which is better, ask the engineers. Again, these architectural shades didn't make a whole lot of difference in our case that we showed. It may make more of a difference in another case. But what we would look at is to make sure the geometry is correct and make sure the materials are correct. Wall and roof colors, again, make sure it matches what was designed. So these are just examples of an insulated concrete form section. And this is the performance value. So what we would want to make sure of is we got the materials that were specified. We got our 8 inches for the concrete pour. We got the thickness we wanted for our insulation. And this is the performance of the insulation. Now, you may have insulation values specified, or you may just have the material specified. Make sure it complies with one or the other. There is a prospect course for building air barriers and pressure testing. So if you go to the purple book, you can find that course. There is a regional center for energy and sustainability for high performance building envelopes. That's Northwest Division, and these are their websites. Okay, so lighting. Okay, lighting, we look at fixtures and ballasts, the submitted equipment. Not only do we need to look at maximum watts, which is power, and power factor, and ballast factor, we also need to make sure that the lumen output is correct. Are we getting enough light? We need to make sure the functional requirements have been met. We also need to make sure the quality of the color is there. Color temperature and color rendering index. Why? Well, if the customer decides that the value or the quality of the light is low in a space, he may end up adding more equipment and using more energy to try to make up for this poor installation. So we need to make sure that these are correct. Whatever's on site needs to match, and we need to inspect to make sure that it matches design. One thing to notice with lighting, it is actually pretty important where exactly the lights are in the room, how high they are, and so forth. Controls, if we call for occupancy sensors, we need to look at where those locations are. We don't want them pointing into a hallway. We want them pointing into the room, so somebody walking in the room sets them off, not somebody who walks by setting them off. We need to make sure if we have dimmer requirements, make sure that we don't have a shadow of them from a cubicle wall or some silly thing like that. We want to make sure if we require automatic shutoff that those are there and they match design. If we call for those to be on occupancy sensors and photo sensors, they need to be there. Here's an example of a submittal. I know that's hard to see for a lighting fixture. I think this is an exterior light. This is the light fixture here. This just defines the light fixture, and here's the performance here for lumen output. So we check the lumen output, make sure it matches design. We make sure it matches the maximum power requirements in the design. So this is not exactly rocket science. It's just a matter of getting used to looking or knowing where you need to look when you look at these submittals. We do have a regional energy center for lighting or natural, I think for daylighting and lighting, and that's Pacific Ocean Division. One thing to note that lighting is required to be commissioned in accordance with our criteria. And note also, if we're already commissioning these, a lot of the activities I just mentioned are being performed. We need to make sure that we're performing some of these activities also, not just leaving it to the contractor. Mechanical systems. We need to, again, this is the same pattern. Make sure submitted equipment and shop drawings and so forth match the design. Whatever shows up on site matches design. The installation matches design. We need to make sure the ducts and piping are sealed and leak tested. We need to make sure that the piping is flushed. These things are pretty important. Let me flip back a few slides here to cost. For duct leakage, a 5% duct leakage in this particular case would have resulted in, and for a 100,000 square foot facility, would have resulted in $2,500 a year in utility costs. For a smaller facility, it's $250 a year. It's relatively significant compared to the effort of walking out and making sure that everything has been sealed correctly or they've passed their duct leakage tests. Strainer, making sure the systems are flushed. If your strainer is clogged, the flow rates are not going to be per design. Either the pump is going to have to operate at higher power, using more energy, or perhaps, let's say it's a chilled water system, flow rate's low, they can't get enough chilled water into the air handling unit, they may just open up the outdoor air wider and allow a lot of humid air to come into the space in order to meet the cooling requirement. So either way is bad. Ensure controls are installed and operate per design. A lot of the energy savings from these systems comes from how the controls are operated, not just the equipment. How are they set up to operate? It's just as important as what equipment is there and the efficiency of that equipment. So some examples. We need to verify the cooling efficiency of equipment. If we have energy wheels, what's the effectiveness of the wheel? Glycol solution. If the glycol solution is too high, then heat transfer is less effective. The fluid is denser. It requires more pumping power. We need to make sure control shop drawings match design. We need to make sure that the air and water balance are within the required tolerance. We flip back a few slides. How much difference does it make? If the balance is 5% over on total flow, that can make $2,500 a year of a difference on a 100,000 square foot facility. If our glycol solution is 30% instead of 20%, that can make a $500 a year difference. a little too far. So here's an example. This is the same submittal we saw early on in the presentation. This shows an air handling system. It happens to have a energy recovery wheel. This is the effectiveness of the wheel. So we look through all this data to make sure it matches what was scheduled for performance. This is a condensing unit that sits outside. We're looking at the efficiency of this unit. So we're also going to look at some of this other performance data, but here's one easy point to check. Does the EER match what was scheduled? This is tank duct insulation. And sometimes it's specified by material and thickness and material density, and sometimes we just specify what the R value has to be. But this is a submittal, and you can see the data is pretty easy to find. If you have any questions about any of these, how to look at any of these, ask your quality management section, your engineers, or ask your engineering department. They'll be happy to tell you how to look at these. Here's an example from a control system. There was a demand control ventilation sequence. What this does is reduce the amount of outdoor air we have to condition based on actual need for outdoor air in the building. The initial submittal was missing the sequence. Fortunately, our reviewers caught it and it got added back in. But we would have lost a lot of energy, we would have lost a lot of money on energy utilities we didn't have to if that had been missed. Here's an example of a point control point schedule. In this case, we see that there are no overrides available to the guys who operate the EMCS system, the people that control the HVAC controls from a central point on the installation. They have no way to override the system. So let's say that a facility is no longer used and they want to make the facility unoccupied all the time and make the HVAC system shut down. Somebody has to manually run out and do that. They don't typically have that kind of manpower. And they should be able to just go into their control system and shut the systems down. Let's say that the operation changes from everybody coming in at 6 in the morning to everybody coming in at 8 in the morning. That schedule needs to be adjusted. In this case, the MCS operator would not have a way to do that. Just one example of how the controls are important. So some considerations here. Again, HVAC is required to be commissioned. Plenty of stuff can go wrong. That's why we've been doing commissioning on HVAC systems for 20 years now, maybe more. I just worked on a recent project where 24 minor to somewhat significant issues impacted energy use, and overall there were 122 issues related to the HVAC system. Fortunately, since we have to commission these anyway, if we pay attention to that process, we're going to catch a lot of this stuff. Again, it requires an intense focus on submittal reviews, evaluation of test plans and procedures, and testing. And the people that do this need to have a high level of competence with these systems. Renewable energy systems, I don't have a lot to say about. Just make sure they're installed and tested in accordance with the design requirements or the manufacturer requirements. One key point is to note that you need to coordinate with the local utilities to ensure all necessary permitting agreements, etc., have been addressed. We've actually had a project where this was not on an installation, but the array was sitting there not operating for well over a year because we couldn't get an agreement with the local utility that had not been coordinated sufficiently ahead of time. So we had a lot of money tied up in a solar array that wasn't giving us anything back. Something to consider. We do have regional energy and sustainability centers for solar PV and wind energy. Their websites are here. There's also one for solar thermal at Southwest Division, and their websites are shown there also. And for meters, I believe the center is Huntsville Engineering Center. Here's the website. We need to make sure we have meters on all the required utilities and that those are connected to the Army Meter Data Management System and the EMCS as required. These meters can be a powerful tool for troubleshooting, making sure the systems operate the way they're supposed to, and assess the effectiveness of future energy conservation measures. So to recap, design solutions incorporated into construction documents represent the best solution for that project based on energy performance, life cycle cost, total cost of ownership, and the amount of funding we have. And if we change anything during construction, it may actually impact compliance with that requirement. It may cost our stakeholders some money in operating funds, or it could, not only from the energy side, but it could increase maintenance. Those are things we need to consider when there's been a deviation or deficiency, or if there's a customer change. In determining whether those are acceptable or not, or whether we have to do further analysis, we need to engage either the engineering office or your quality management office or the AE to determine how big an impact is this going to have. When we actually apply our quality assurance measures, we need to consider the relative impact of various energy conservation features or systems. How important is it? How much time do we spend worrying about wall and roof color? Would we be better off spending that time on air barriers and making sure the duct system is constructed correctly? And when you need help, don't be shy about contacting the regional energy and sustainability centers. They're there to provide information, so reach out to them when necessary. If you need help on anything, if I don't know the answer, I'll try to find the right people that have the answer. There's my contact information. That's all I have, Eric.
Okay, I'll try to speak a little softer. I had to turn up my volume quite a bit. I opened up the Q&A box on the right-hand side of your screen. If anybody wants to submit a question, there's a text entry box at the very bottom of that white column. Your questions will only show up to me in the column above, and I will consolidate and read them aloud to Brandon so that he can answer them, and we can pick that up on the audio. A couple things I wanted to recap just briefly here. One of which I added a link down here to the ECB 2014-16, which is where we put out a draft of a quality assurance guide for building envelopes. We are in the process of adding that to the engineering pamphlet series on quality assurance as a permanent part of our field records. And also on the right here is a link to the Mercy site, as I call it, the Sustainability and Energy site. That's, again, where you can find your quizzes for your CEUs. And also, as I mentioned, this webinar is being recorded. It'll be uploaded to our unlisted YouTube channel. So you can go there on this past webinar videos, follow that link, you can bookmark it if you want, and view our past webinars if you need some refreshing for the sake of the quizzes. Down at the bottom block, we have the file share. There we have a copy of this presentation. There were a lot of good links and information that Brandon presented, and so you'll have access to those. One thing I wanted to cover real quick, Brandon went back and forth to the example graph, which was very interesting about the effects of those changes on the building, and I didn't want people to come away with thinking that those things were true for everything. As he did correctly say initially, that it depends on your climate, where you are, your building geometry and such. For example, the solar shades, if you're in a place other than Kentucky, you know, someplace with a bright sun shining horizontally into the windows, then of course having a significant shade that actually blocks that sunlight would be much more effective. But if you have a very shallow shade and you have a deep angle of sun, the sun's just going to go right under them, and it's kind of pointless. So I have a couple questions coming in. Oh, let's see. First person says, please provide Brandon's contact info again. There it is. Next one says, who provides the funding of the HVAC commissioning?
Okay, so for Army projects, typical commissioning is funded by the construction funds. So the funds identified in the 1391 for construction of the facility, commissioning costs for the contractor side come out of there. If the elements that the court are involved with partially are S&A funded, anything that's quality, mostly, I mean, pretty clearly quality assurance related would be S&A funded. Anything involved in design elements would be DDC funded. If additional commissioning is required, a higher level of commissioning, do we want a third party, those kinds of things, those would need to be come from, well, first, could come from construction funds, but we need customer concurrence to use those funds for that purpose.
Okay, there's another similar kind of question. Who pays the AE for re-engaging when the contractor has requested a deviation/variance in a design bid build project?
Good. So often we have Title II services with AE firms to review submittals, and we would use a similar vehicle to get back to the AE. The funding would have to come out of Design During Construction, DDC funds. So I would highly recommend that you look to your engineering office or look to your quality management or office in construction if they have an idea of whether something has a high impact or not and whether it's worth going back to the AE for that. And it may be cheap enough just to ask the AE a quick question and ask, we're thinking this is going to be a change. Do you think this is a big enough impact to be concerned about?
Okay. The next question here is, where is a good source for RFP content for the requirement of energy modeling? I could not find anything in our RFP wizard templates that addresses this.
Okay. Well, nothing has been built yet, I don't believe, that reflects the new ECB 2015-7, which requires that we do optimization pre-award. We basically would do the optimization ahead of and incorporate the result into the RFP prescriptively. Here's the systems you're going to put in. Here's the building envelope you're going to put in. Now, as far as requiring energy modeling and life cycle cost post-award, it is a struggle. I don't know that there's any good language out there for that. If you want language to use for an AE scope of work to develop an RFP, let me know. Send me an email. I can send you some language we worked up for the Army Reserve program.
Okay. There's another question on the meters. George Riley asked, and George, feel free to re-comment if I get this wrong. On the meters, we did that here. I'm guessing he's from an installation. But now that H&C, the Corps, is doing the MDMS upgrade, we're having issues with the meters that we installed being added to the contract. We might lose what we already paid for to install already. I don't know if that's a compatibility issue or...
I don't know how to answer.
George, I'm going to ask you. Yeah, George, if you could elaborate on your question a little bit. In the meantime, let me go to the next one here. In regard to the O&M evaluation/factor, is there a standard for Army installations to use? It could vary from no maintenance or if they only fix it when it breaks because they're overwhelmed. Basically, is there a standard for O&M evaluations and factors? I assume he means during the cost of
No, I know what you're talking about. There are installations that are break-fix only due to manpower issues or funding issues. They wait until something actually fails, and then they try to find the path of least resistance to get the occupants keep them from complaining, which may not be the correct fix either. So I would say I'm not going to say this for all installations. That'll get me in trouble, but I know several that's how they operate. They won't be shy to tell you that. And you can't incorporate that level of maintenance into your life cycle cost analysis. You really have to assume that they're going to take care of the system the way it needs to be taken care of. And the only data I can think of that's easy to get to is RS means. ASHRAE has a database that has various data in it, but there's not a lot of data points, so it's not very reliable. And we are actually, I'm going to meet with one of our installations Thursday to see what we can do about getting what maintenance cost information they have. I don't think it's going to be easy to process. I think in the end, you're going to have to fall back on RS means. That won't reflect reality, but that's probably the best data we can get at the moment. I hope that answered the question.
Okay. I'll let him repost if it didn't. Okay, so George is back. He said basically no part of the WEC original contract. Um, so since we are required to install the meters, why would they not be automatically become part of the core contract to keep them incorporated into the new MDMS? They were installed to the core standard at the time of the install. I think that might be something maybe we need to take offline for the metering people. It might have been something to do with the Army standards that were issued, I'm guessing, um, yeah, for compatibility. Unless you know something about that, Brandon.
No, but
Maybe we
we
have some
have
other
some
people.
struggles with that ourselves.
Yeah, I know meters have been a touchy issue ever since I've been at headquarters. So many systems out there that were put in for compatibility across the installation, then turned out to not be compatible Army-wide, and when they developed those standards, after there was a mandate for all agencies to roll up their energy data through centralized metering systems. So George, we'll have to take that. Send one of us an email to follow up. We'll have to take that one offline. I think we can probably connect you to some metering experts. Sometimes those standards change. Let's see, who determines a third level party commission? Who determines the third level party commissioning?
The person who's going to pay the bill. So on the, for instance, on the Air Force, we just did a project where they wanted us to have a third-party commissioning of a project. So we pursued that, and we had permission to use their construction. I'm sorry. During design phase, we had to use P&D funds. During construction, we were using construction funds to fund that. On the Army Reserve, a couple of projects they've done that. The education systems, ODEA, and MedCom often want a third-party commissioning effort also. Generally, Army MilCon, we don't hear a request for that.
Okay. Oh, we're a little bit past the hour now, so I'm just going to take this one last question. Says, I believe Brandon mentioned a new requirement to maintain a report in the real property record. Please confirm this and repeat what document defines the requirement.
I,
Is that related to Builder?
I don't recall the talking about real property records.
I know the one thing we are working on is getting the energy and sustainability record card. That's right now a spreadsheet that has to be submitted, and there's an ECB about that. And it's also written into the UFC 1-200-2 that requires the submission of the record card for each of the services has their own record card. But we're trying to get that integrated into the Builder system that tracks all this stuff for existing facilities. So basically the data would be input on the energy models and all that during the design, and then they would be a switch would be flipped in Builder, and it would just become part of the existing record once the building is turned over. So I don't know if that helps Mr. Hip or not. But anyway, I think we need to wrap this up since we are a bit over the hour. Thank everyone for participation, and we apologize profusely for the miscommunication about what link to get here. I'm glad to see that we had over 60 people online, so enough of a group out there figured it out despite our wayward leanings. So thank you again for joining us, and there will be announcements in the future for our next webinar series. Thank you again, Brandon, and have a good day.
Thank you.